Hello, everybody. Thank you for joining on to this video to review our lesson 4 for module 6 from class. We were rewriting fractions with a common denominator, and everybody was doing a great job in class. Let's take a look at our more practice and homework page and see what's happening here. There it is. All right, so we're going to start off with the problem as a little situation. It says Luis reads about 2 popular cell phone apps. One app uses 1/2 of a phone's storage space. The other app uses 5/12 of a phone's storage space. Explain how Luis can find the difference in the storage space of the 2 apps without drawing a visual model. So if one of them is using 1/2 of the storage space and one of them is using 5/12, we talked about in class, instead of drawing a visual model, we can list our multiples of 2 and 12 to find one that they have in common or one that they share, right? So that would be one way, and to find that difference, I would list out, for example, 2, 4, 6, 8, 10. Now I've gone out 5 places like we've been doing in class, but if you notice, I have another denominator of 12. And when I've listed out 5 places, I haven't even gotten to that 12 yet. So I'm going to go one more place, and then we would know that they share that multiple of 12. And then we would be able to compare and find the difference between those two. Another way we talked about in class to find how we could find that difference, because we need fractions that have the same denominator, as we said in class, that means that the sizes are the same, and then we can combine or remove those same size pieces like with our fraction tiles. What I can do is I can find the product of my denominators. So I can, let me write that. I can find the product of the denominators, which would be 2 and 12. So then our denominator would be 24. Now, as we said in class, I keep referring to class, you've heard this before, hopefully. That might not be my least or my first common multiple, but it is a common multiple and will allow me to add and subtract those fractions. Okay, so those would be 2 options or 2 strategies that we might use. Good. So moving on, let's find some equivalent fractions with common denominators. I have 4 and 3, so I could multiply and find that product. So that would give me a denominator of 12 for each of those. 4 times 3 is 12, so I have to do 1 times 3 for my numerator. So 1/4 is equivalent to 3/12. 3 times 4 is 12. I have a 2 here in my numerator, so I have to do 2 times 4 to get 8/12. And 2/3 would be equal or equivalent to 8/12. All right. So as I look at the next one, 11/12 and 1/4. If I think of my multiples of 4, I list them out. Oops. 12 matches. I don't even have to change that 11/12. It can stay the same. 1/4 has to be adjusted and renamed. If I'm now splitting those fourths into 12ths, if I have 1/4, my 12ths are going to be smaller. I'm going to need more than just 1. So I have to think 4 times 3 is 12. 1 times 3 is 3. Okay. Continuing on, I have thirds and fifths. I'm going to list out my multiples this time. 3, 6, 9, 12, 15, 5, 10, 15. Ding, ding, ding. We can stop right there with our multiples of 5 because we have a common or shared multiple. Sorry. So we're going to use 15 for our denominator. 3 times 5 is 15. 1 times 5 is 5. 1/3 is equal to 5/15. 4/5. I'm adjusting and renaming that as 15ths. 5 times 3 is 15. 4 times 3 is 12. 3/5 and 1/3. I just did fifths and thirds over here. I'm going to look back at that. I'm still going to use 15 as my common denominator. That doesn't change, but now I have 3/5. So 3/5 would be the same as 9/15. 5 times 3, 3 times 3. 1/3 would be the same as 5/15. 3 times 5, 1 times 5. I have 6ths and 12ths. Right away, my brain is jumping. 6, we can rock and roll because 12 is a multiple of 6. So I'm going to adjust both of them to 12ths. Now, I don't have to do any work for 1/12. It can stay the same. 6/12 is going to be renamed as the equivalent fraction 10/12. 6 times 2 is 12. 5 times 2 is 10. And then 3 and 8, as I'm thinking just in my head of these multiples, I'm not coming up with one that's jumping right out at me. I'm going to multiply. I'm going to use that denominator and multiply my, and get that product of those two denominators of 24. So I did 8 times 3, I'll do 7 times 3. I did 3 times 8, I'll do 2 times 8. And there will be our equivalent fractions. All right. Math on the Spot is the video going through Clever to our Into Math curriculum. You can watch that video, get a little different voice and perspective than mine from someone else leading you through that situation, number 8. If we go to the back, test prep. Our test is tomorrow. This is it, last lesson of this module. We're going to select all the common denominators that can be used to write equivalent fractions for 4 and 8. So if I have to choose all of them from this list, I'm going to list out my multiples, 4, 8, 12. It goes, my last choice is 24. So I want to go out far enough that I am at or past 24 with these multiples. So I'm going to go a little bit further than 5 here. 4, 8, 12, 16, 20, 24. I'll stop there because that's my highest answer choice. When I do 8, 16, 24, I can stop right there. So both of these share an 8. So letter B is going to be one choice. They both share a 16, letter D, and they both share 24. So we're going with B, D, and E. I would not choose 4. 4 is a multiple of itself, but not of 8. And then 12 is a multiple of 4, but not of 8. So that's why I would not choose A or C. Number 10, Kai asks the students in her class to vote on places they would like to visit. In the class, 3/20 vote for a large city. 3/5 vote for the beach. And 1/4 vote for the mountains. Write a numerical expression using equivalent fractions with a common denominator to model the part of the class that would like to visit these places. We did these working together today. I went to look at my 3 fractions. I have 3/20, we have 3/5, and we have 1/4. So looking at those denominators, 20, 5, and 4, I'm going to leave 20. That's a pretty large number. And if I think of my multiples of 5, 10, 15, 20, I can adjust and make an equivalent fraction for 3/5 and make that into 20ths. And for 4, 8, 12, 16, 20. Again, I can rename this fraction and make an equivalent fraction using 20ths. So my numerical expression, do we need an equal sign for an expression? We do not. So I'm going to start with 3/20. I did not have to change that fraction at all. The denominator got to stay the same. We are modeling the part of the class that would like to visit these places. So we are adding for 3/5. If I'm going to make that into 20ths, 5 times 4 is 20. I already had 3/5, so I need to adjust now into 20ths. I need more than 3 3 times 4 is 12. And finally, 1/4 would be the same as 5/20. And we're finished with number 10. That is our numerical expression with equivalent fractions and a common denominator, modeling the part of the class that would like to visit those places. Good, good, good. All right. Use a common denominator to rewrite 7/10 and 8/15. So tenths and 15ths. Woo, let's see. I can do tens pretty easily. 10, 20, 30, 40, 50. So 15, 30. Oh, woo-hoo! I don't have to go any further. Whew. Getting higher with those bigger numbers. It might have taken me a little bit longer there. All right. So we're using that denominator of 30. 10 times 3 is 30. I have a 7. 7 times 3 is 21. And 8/15. If I'm doing 30ths, 15 times 2 is 30. 8 times 2 is 16. We just rewrote those with a common denominator. We are finished. All right. And what fraction pair shows the fraction 5/12 and 3/8 expressed with a common denominator? Is there going to be more than one here? Let me check. There might be. Nope, just one good answer. Okay, so if I can do 24ths, 12, 24, 36, 48. Oh, it goes higher. 48, 60, 72, 84, 96. I'm going to stop there because I had 96. Oh, now the 8 all the way to 96. Oh, I wonder. 8, 16, 24, 32, 40, 48. Oh, where am I? 1, 2, 3, 4, 5, 6, 7, 56, 60, 56, 64, 72, 80. Oh, I was getting lost where I was on my multiples of 8. All right, I'm going to stop right there and just see what happens. If I adjusted to 24ths, 12 24ths would be 10 24ths. Notice that 5 in the numerator didn't change. So right away, I'm not even going to check the rest of that because that is not even the correct matching fraction or equivalent fraction for 5/12. 40 96. If I'm doing 12, 1, 2, 3, 4, 5, 6, 7, 8. 8 times 12, 8 times 5. So that's good. I'm going to put a little star there. 96. I have to keep going. 88, 96. I had to go a little further out with this one. 8 times 12, 3 times 12. Oh, that's good also. All right. That looks good. I want to double check. I said there was only one right answer. We better make sure. So if I have 48, 12 times 4, 5 times 4, that's good. 8 times 3, 3 times 3. Oh, that one's no good. C can't work. And then 36. I have 12 times 3, so I need 5 times 3. That's a good one. 8 times 8, 16. Wait a minute. 36 is not even a multiple of 8. That's no good. All right. So letter B it is. Winner, winner. All right. There is some spiral review. A baseball league has 176 baseball players divided equally into 16 teams. How many players on each team? If I'm dividing them equally, I have 176. I have to go really tiny over here. Divided by 16. 16 does not go into 1. It goes into 17 one time. I subtract and bring down. 16 goes into 16 one time. It would be 11 players on each team. That worked out nice and neat. Arun travels 24 miles each hour on a 102-mile bike trip. How many hours does his trip take? 24 miles in an hour. So we're going to do 102, sorry, divided by 24. 24 does not go into 1. It does not go into 10. It goes into 102. I'm going to say 4 times 8. Oh, I'm sorry, 16. 4 times 4 is 16. And 9. When I subtract, I'm left with 6. How many hours does the bike trip take? I'm going to say 4 hours. That's total hours. But we still have 6 left over. If we've talked about this in class, I'm going to make this a fraction. I'm going to do 4 hours and then 6/24 of an hour. So it really would be about 4 hours and some more of the next hour. So a little bit more than 4 hours. Okay, you could write that a couple of different ways. It could also be written as 4 1/4 hours if you simplified that. And finally, here we go. Jorge uses centimeter cubes to build the right rectangular prism with no gaps or overlaps. Describe how Jorge can find the volume of the prism. Very simply, right? He can multiply length times width times height to find the volume. Because there are no gaps or overlaps, we can use that formula. Good. All right. That's it for our lesson 4. I hope you feel good about it. Please bring questions and comments to class tomorrow or the next time we meet so we can clarify anything where there might be some confusion. All right. That's it for now. I will see you later.